Start. Hello friends, today I am going to teach about special topics in quantum mechanics, and first our first topic is how to change the basis. So change of a basis. So बेसिस चेंज करने के लिए हमको दो चीज़ों की ज़रूरत होती है. फर्स्ट, वो उसका all elements in vector space they must be linearly independent. They must be linearly independent. And they must span the space. So let us take position vector r vector, that is equal to x e x cap plus y e y cap. So here e x cap and e y cap are the base vectors. E x cap and e y cap both are base vectors. So now if I take r dash, that is equal to x dash plus ex dash plus y dash ey dash. Okay, now if you transform the coordinate xy to x dash y dash, similarly we can write ex and ey, and we can transform these to ex dash and ey dash. Okay, so now I take kate alpha. This is our kate alpha, and this is the linear combination of C1 1 plus C2 0. Okay, and this 1 and 0 are the eigenkate or the base operator of the SZ. Okay, so this C1 square is the probability of finding C1 square is the probability of finding in the state 1, and C2 square is the probability of finding in the state 0. Okay, now alpha is equal to C1 prime 1x plus C2 prime 0x. This C1 prime and C2 prime are in the SX basis. So first, when we write before that alpha is equal to C1 1 plus C2 0, this eigenkate 1 and 0 both are in SZ basis. Now we transform this into SX basis, and C1 prime and C2 prime is our new constant. So now 1 change to 1x, 0 change to 0x, and C1 change to C1 prime, C2 change to C2 prime. Okay, so now one completeness relation. What completeness relation says? It says that our summation ei cap ei, that is equal to 1. Okay, this ei is our base vector and this is our kate. So any element in our vector space that represented by kate vector and bra vector, those multiplication that will gives 1. That is our completeness relation. Now I can write ex cap as 1 0 and ey cap as 0 and 1. Now I can write r vector xy that is equal to ex cap x 1 0 plus y 0 1. I can write this as a linear combination of both vector. Now ex dash that is equal to summation I ei cap ex prime. Actually I want to write this ex vector ex dash get in form of ei and ex. So this ei cap and ei combination is 1, our completeness relation. So I can write this ex prime, I can represent this ex prime as this. Then similarly I can write this ex cap ex prime ex as ey cap ex prime ey. I can write this as linear combination of ex vector and ey vector. So I can represent this in form of ex dash. Similarly, I can write for ey dash. Ey dash is our base vector that is equal to ex cap ex ey dash ex dash plus ey dash ey. Now I can transform the coordinate ex dash ey dash. Ex dash ey dash are our new coordinate, and these base vectors I can write in the form of ex dash ey ex dash ex ey dash and ey dash into ex ey. So I transform this new coordinate into old coordinate. This is our matrix representation. Okay. Now I can write this as ex prime ey prime that is equal to cos theta sin theta minus sin theta cos theta ex ey. So how I can write this cos theta sin theta and minus sin theta cos theta? I am telling now. Now I am taking rotation of coordinate. This is our x and this is y. This is x dash and this is y dash. Okay. So this angle is theta, and this angle is also theta. This angle, this is our 90 degree, and this is also our 90 degree. Okay. So it means our unit vector is along ex cap, and this x dash is unit vector line as ex dash, and this is ey and this is ey dash. Okay. So now the x dash projection on x is cos theta. Okay. And y dash projection on y is sin theta. So I can write this as in terms of base vector ex dash ey dash that is equal to cos theta sin theta minus sin theta cos theta ex ey. This x dash on x is cos theta, and this y on x dash is sin theta, and this y dash on x is minus sin theta, because cos 90 degree plus theta, that is minus sin theta. and this projection on this is y dash on y is cos theta. So this is our transformation of coordinate in or orthogonal base vector in ex dash ey dash in terms of ex and ey. Okay. So these are nothing but the inner product of the base vectors. Pause कर दे वीडियो. Now I can write 1 x as I
let x
1 x that is equal to summation of
ये क्या रोज़ा भी तो इतने शाही लोग हो तुम
1 x where I is equal to 1 and 0. So I can write 1x as linear combination of 1 1x 1 plus 0 1x 0 and 0x as this is I am writing in Sx basis. So I can write this as 1 0x 1 plus 0 0x 0. Okay, so I will write now in matrix form. One x 0x this that is equal to this is our base vectors. Okay, so I can write in 2 cross 2 matrix 1 1x 0 1x 1 0 0 0x. X I am writing x dash is equal to ex dash r. So it means what does it indicates? It indicates ex dash projection on r. It means what is how is the projection? This is x, okay, this is y and this is our y dash and this is our x dash. Our r, what is our r? R vector is equal to x I cap plus y j cap, or I can write x ex cap plus y ey cap. So this x prime projection on x, this x prime is along ex dash. Okay, so this ex dash projection on ex, that is this. So I can define now unitary operator, that is ex u cap r. I can write this as ex dash summation of ei cap ei cap r vector. So I can use completeness relation here. So this ei this equal to 1. So ex dash r is same as this explain. Now similarly I can write this same as for y dash. For y dash, how I can write e y dash summation e1 dash e1 r. Okay,
पास कर दे.
so now I write x dash y dash in matrix form. So ex dash ex and ex dash ey and ey dash ex ey dash ey. x and y. Now I define C1 prime. Firstly I define what is C1 prime. C1 prime is our new basis vector in terms of Sx. So C1 prime x1 alpha, that is equal to 1 u prime alpha. This u prime is our unitary operator. Okay. So now I can write 1 summation of I alpha. I can take any values, I 0 1. So similarly C2 prime, I can write as x 1 alpha, that is equal to 1 u prime alpha. One summation of I alpha. Okay, so I define your C1 prime and C2 prime. So C1 prime I can write as C1 prime is equal to 1 1 x 1 alpha plus 1 0 x 0 alpha. I can write this in term of ket alpha. Okay. So similarly I can write C2 prime. How I can write C2 prime? X 0 1 1 alpha plus x 0 0 0 alpha. Okay. Now I can write in matrix form C1 prime C2 prime, that is equal to summation x 1 1 x 1 0, okay, 0 1 x and 0 0 x C1 C2. Now I can write 1 x as unitary operator 1 and 0 x as unitary operator 0. Okay. Now I can write here our new is equal to u divert into old. Now I am writing a question based on our theory, Sx basis and Sz basis. So one question, if alpha is equal to 1 by root 5 I2, okay, and this is in Sz basis, okay, Sz basis. So if we measure Sx, Sx prime, Sx, so what is the probability? Of getting 1x? This is our question. Okay. So given the question is in Sz basis. So in this Sz basis, now I want in the given question I measure Sx. So first the question, in the given question, what is the probability of getting 1x? So I can write first alpha, that is given 1 by root 5 I2. Okay. Then I can write this in term of C1 prime and C2 prime. It is in Sx basis. Given C1 prime 1 plus C2 prime 0. So I can write this as 1 by root 5 I2 into 1 by root 1 plus only for C1 prime na, so this is only for C1 prime. Okay, so now I have to find the probability. Probability means C1 prime square. It means okay. So C1 prime I can write C1 prime as 1 x C1 plus 1 0 x C2. Okay, so I can write this as 1 by root 2 into I by root 5 plus 1 by root 2 into root 5. Okay, this is root 2 and I can write it as I by root 10 plus 2 by root 10. This is our C1 prime. Okay, so now our main aim is to find probability. So probability is C1 prime square, that is equal to I plus 2 by root 10 whole square, that is equal to 5 by 10 into 1 by 2. This is our probability for finding C1 prime. Similarly we can find for C2 prime, but this is not in our given question. Similarly we can find for our C2 prime and it will give C1 by 2. So our total probability become C1 prime plus C2 prime, that is equal to 1. This is the given question. Okay. From C1 square plus C2 square, that will be 1. C2 square. This C1 square is 1 by 2 and C2 square is 1 by 2. So total probability is 1. But in our given question it is said that to find the probability of C1 prime. Okay. Thank you.